In 2005, we began with, 2006, we began doing condition assessments. Now that we had an inventory in place, we're now able to use various technologies to start assessing the condition of our roads, sewers, sidewalks, and storm infrastructure. Some of that technology you see here on display today, we have robotic camera equipment that go through sewer pipes into some very harsh environments. They range. This one here is a very simple unit. They get very sophisticated from basically little camera launchers that go up laterals with gas sensors on them, radar, all kinds of different sensors on these equipment that all provide electronic feedback. What's different on our approach here is all this technology is widely used in the industry. Most of that input is textual-based or video, and it's a very manual way of processing it. Our process is now a full automation from our site to our contractor and back. It's all electronic, all electronically processed, and give us that information with very little manual input. There's still an operator that helps push that information through and reviews it and does quality control, but there's an awful lot of automation that goes in that makes that, streamlines that process very significantly. At the same time we did that, we also, while the base GIS technology was ESRI, we needed to make that information available to all of our internal staff, and the easiest way to do that was implement a portal technology, and we've chosen to implement Orion's OnPoint GIS portal. And that's a worldwide, world-leading system as well. 2007, we continued with ongoing pipeline condition assessments. One of the photos you'll see later is called zoom camera technology. It allows us to quickly insert a camera into manholes and pipes using very sophisticated focal and lighting systems to be able to zoom up a camera and get a very quick assessment of that pipe. It allowed us, within 2 years, to assess almost 80% of the system at a very low, reasonable cost. The detailed inspections that we follow up is a very long-term, costly exercise, but very necessary. That early-on approach allowed us to very quickly identify where the higher priority issues that we followed up in prioritization with that kind of technology. In 2008, we implemented IBM's Maximo Work Management System, which a lot of our discussions have been today in our operations and maintenance divisions. 2009, we enlisted the help of one of our consultants to do a life cycle analysis and long-term financial sustainability plan. At the same time, we've also completed the full integration to PSAP reporting. For some of you that may not know, the Public Sector Accounting Board and the federal government had implemented some new legislation around how assets need to be reported on the city's municipal balance sheets. And very different approach than what has been done before, but it's equivalent to the private sector approach, where all of your assets need to be detailed and shown on your balance sheet. Our implementation, I believe, and I'm not aware of any other municipality in Canada that has achieved this, is a full integration of our detailed assets directly into our tangible capital asset system. Most other implementations have been done based on estimates. Ours are done on factual data. And finally, in 2010, you referred to earlier a 10-year capital forecast. This is the first year that we've got a full identification of all of the roads, water, sewer needs, sidewalk needs, and they're all being gone through this process here, integrated capital planning. And I'll talk a little bit more about that in a few minutes. But that's going to be a very different approach to our capital plan and our capital budget process, where council and the public will have a much better knowledge of the kinds of work that needs to be done much further out in the future than has been done before, and allows us to do a much better financial plan and funding plan. A little bit about a summary of our assets. Earlier I mentioned we had 250,000 assets that we track. This is kind of the breakdown of where these things sit, and our total value of about $1.2 billion in current replacement values. The interesting thing that you will note here is these are typical lifespan of years of these individual assets. This is our average age of those assets. Now, in some cases, you'll know some very interesting things. For example, our bridges, there we go here. Typical life of a bridge is 50 years. Our average life is 45. We have 24 of them. Now, this is not to say that these bridges are in poor condition, it's just a very good indicator saying, look, we need to spend some time and some effort looking at our bridges to make sure that they are continue to be safe. And we do that. Every 2 years, all of our bridges and culverts are inspected to ensure that they remain safe and they're structurally sound, and we keep up with those repairs. But these are kind of indicators saying this is where you need to start paying a little bit more attention to these assets as they approach those normal end of serviceable lives. We have our dams. We have 2 dams for some of you who live in our city. The typical life of a dam is about 50 years. Our average age is about 102 years. And yes, those are very big red flags. In fact, once we took a closer look at those, once we established ownership of those dams, which did fall into Cambridge's lap, we undertook emergency structural repairs to mitigate that issue. These are of high focus in the next couple of years to try to resolve how to deal with those.
Just a quick
I know you have something to say.
I have to comment on this. We acquired their orphan dams, that's the term we used. We ended up acquiring them from what we felt was a provincial responsibility. Some of these dams were built at a time when they were operating local mills and so forth. So they've been around a long time, but we have now assumed ownership. So we hope those numbers change shortly. Sorry, I had to.
But as I said earlier, this is not an indicator of condition, but it's an indicator of how much attention we need to give to some of these assets. Just like your aging car, that you need more frequent inspections, these are that kind of indicator saying, hey, these assets are aging and you need to pay much more special attention to them. Some of the key issues that we've uncovered and we've now been able to quantify. First of all, the system has in fact aged faster than our renewals. So the system, and there's multiple factors that go on place. First of all, the number one effect is an echo effect of the building booms. Over the past century, as the municipality has grown, there's been decades in time where we've gone through building booms. The 1960s and 70s is a good example where we constructed a lot of subdivisions, a lot of homes. Well, that has created a bubble in terms of the infrastructure. We have a bubble of this infrastructure's quantity of infrastructure that, unfortunately, the materials used to build the water systems were not as good as that they were expected to be. And in fact, 98% of all of our water main breaks are because of this particular material type of water. Water systems are expected to last anywhere from 70 to 100 years. These particular pipes are only lasting 40 to 50 years. So that is a very good case of where infrastructure is not achieving the serviceable life, and now it becomes an issue. In fact, that's where much of our operating and maintenance costs are going today, is reactively repairing those things that have failed that really needed to be replaced a few years ago. Fortunately, we don't have the funding, have not had the funding available to deal with those things. So this spiral continues on. And we've now quantified that in the water system. There's a $54 million backlog in this inventory. Put it in perspective, our annual water renewal budget is typically $2 million. All right, so a $54 million backlog in water systems is quite significant. In fact, it represents about 20% of the water system in Cambridge. The sewer system, we have not had material issues in that case. That $17 million backlog represents sewer systems that in fact have aged. Primarily clay pipe, installed pre-1960s, 1950s, and that represents that number. I believe it's somewhere around 8% of the system. Because this infrastructure gap, and because we have a high rate of failures of these particular materials on the water side, and we have aging sewer infrastructure, that has put a very dramatic increased pressure on our operations and maintenance crews. The reactive repairs, we all know that reactive repairs either not only cost you more, but it also takes away from your ability to do ongoing maintenance and inspections on other stuff that's still good. It's like that good car that's sitting in the driveway. If you don't have the resources to change that oil, you can do that maybe once or twice, but you can be sure that you're going to have some unexpected and early repairs that need to be done. So, as I said earlier, this is not a critical stage for Cambridge, but we're certainly at an area of concern that we need to address this quickly. And I'll talk a little bit about how we're dealing with that and how we are managing that. We have some direct increased expenses as a result of this infrastructure gap. I'm going to switch here so I can see. Water loss. Our water loss in the system has increased slowly, incrementally over the last 10 years. At this point, that water loss equates to about $2 million on an annual basis of our expenses line. And to give you some perspective, that is the equivalent water consumption of about 12,000 homes. So it's not realistic for us to make that water loss zero. That's not a realistic expectation. But it is realistic that we can likely half that water loss when we replace those older those systems that are breaking. That means that if we actually achieved half the efficiency, improved half of the water loss in the system, means we could add 6,000 homes to this municipality without drawing any more water from the wells, the groundwater. And that's a very big impact on the environment.